and he is currently working as a data scientist, research scholar with Object Automation Software Solution Private Limited. His research areas include scientific big data analysis, HPC, artificial intelligence, blockchain, and decentralized technologies. So, thank you, sir. I over to you, Mr. Abhishek Sharma, sir.
Uh, Thank you, sir. Thanks for the nice introduction.
Thank you, Abhishek. Thank you.
Hi, I'm Abhishek Sharma. I work with object automation, mostly in the deep learning projects or data science project. I research in on these areas. So for today's topic, I'll be presenting on uncertain knowledge and reasoning in AI. So when we work with AI, we at like most of the time we face uncertainties in data, or you could say the data is not clean or data is not certain. So we have to predict or we have to label it. All these things we come across, but that is the part of practical theory. Today, I'll talk briefly about the agenda of my presentation is the uncertain knowledge and reasoning, and what are the causes of the uncertainty and probabilistic reasoning, like how we use probability in AI and the Bayes rule, Bayes theorem. All these things I'll talk about, and in the end, one project which I recently worked, or you could say I implemented is signature forgery detection using CNN network. So briefly, I'll talk about this project also. So these are the area I'll talk. I'll start with uncertain knowledge, like what is knowledge for AI and what is the uncertainty in that, and the probability we use with the to counter this uncertainty, and then the project areas. So, what is uncertain knowledge, or you could say what is knowledge representation and reasoning in AI? So, how human work is that they know certain things, they understand knowledge, they take rational decision, they are able to understand, interpret the surroundings, and after doing all these things, they take some actions according to the real knowledge, like real information they understand. But to the system, to like to a machine system or to a AI system, what is real knowledge, what is the certain knowledge, what is the labeled data in terms of practical knowledge we we present to it, as it's come under this domain of knowledge representation and reasoning. So here, the knowledge representation and reasoning, it's that part of AI that makes AI uh, think about it or work on it and behave in certain way and predict it or classify in certain categories the objective that we wants to fill with AI, um, fulfill with AI. So knowledge representation is very important for the AI, or you could say the machine. uh, it is responsible, like the right knowledge or right representation of information is responsible to understand, for a computer to understand the problem and then develop some AI model and work on it and develop a solution in the end. So in this area, we work like how we can describe the what all information we have and how we can represent this knowledge to the AI. So the knowledge representation, it is not just the data, but some kind of prediction with it, like some kind of analysis with it to give it with a to give it to a AI or a machine so that it could behave intelligently, like it could perform certain action, and so that we can work upon it. So, what is the you could say what are the types of knowledge? Like what are the things in data? So one is the facts or the information. Like some, if the data is about someone's age or someone's date of birth or someone's marks, so this is called as object. And then the event that happens in the real world, like a you could say the climate change events, the rising of oceans, all these events that happens in the real world, we can counter, we can say that these are the, part of knowledge. Then the performance. Performance means that how the uh, like how these events behave, or how the behavior of a particular system is, so that is also part of the knowledge for the AI. And then meta knowledge or metadata, it is data about the data, or the knowledge about we know. And the facts are the like truth, or the information, or the data about the objects, or about the things that we present or that we give to the AI or the machine. So these are the types of knowledge that is represented in AI system. Basically, in AI or in a machine learning model, we give it some data, and data is about either it is about some facts, or it is about some behavior, or it is about some predictions. All these things comes under the domain of knowledge. So knowledge is that certainty, or that familiarity with the facts or the data. And the computer system, the machine learning model should able to grasp that knowledge, or grasp that data information, so that it could make something out of it. Now, what are the issues related with the knowledge representation? So one is the relationship among the attributes, like what all data that we give to the AI, what is the relationship between them? Is it right or not? Is it describing the that object or that particular domain in the correct sense, or in an incorrect sense? So one issue the knowledge representation is that. Second is that how much information is necessary for the machine learning system to adapt to it, or AI system to uh, learn from it. Like how much detail do we have to provide it for it to perform efficiently? And then representing sets of object. Sets of objects means that for an example, like all the properties, are we providing all the properties that satisfy the given set together as an individual? And then the finding the right structure as needed. For an example, uh, what all data that we provide to a AI model or a machine learning model in a particular situation, how it is structured, how it is going to perform that training and validation. So how it's going to, is it in the right structure for that particular model or not? So it's a part of data, you could say data wrangling or a data cleaning. So all this knowledge, like knowledge representation things, we have some issues. So issues is with like relationship with the attributes, or the detail of the representation, or how much information that we want to represent in the data. So this is the knowledge representation issue. Now comes the uncertainty in the knowledge. So when we are sure that something is true, like some knowledge is certain, so we can certainly say that A, when A is true and so B is true. So if A is true and then B is true, and we know that A is true, A with certainty, then we can conclude that B is true. But at times it's not possible to tell like is it true or not. So we cannot conclude from it that B is true or not. Like if A is true, A with certainty, like that this knowledge is certain, so we can conclude that okay, now B is also true, and B is valid, like B condition, right? And uh, so what happens is that sometimes like we don't have enough evidences to say that A is right or A is true, and we cannot conclude then B is true. So this is the uncertainty in the machine learning domain or AI domain, that we are not sure about certain condition. So this is the uncertain knowledge, and then we have to predict it using uh, some some theories or some logics, probably using probability, which I'll talk later, like basic of probability. So we can use the probability. Okay, the probability of A being true can be 80% or the 90%, so that we can say that B can also be true 90%, like that. So uncertain knowledge is, yeah, uncertainty belongs to that we have not right representation of knowledge A, so that we cannot conclude that B is also right. So, what are the causes of uncertainty? And causes could be that information, the data that is coming from whatever the source is not reliable. It might have some faults in it, or there is some unreliability in some sense. Then there might be some experimental error. So experimental error means like the devices or the equipments that we use might have some issues, and they represent those data not in the right sense. And then other factors like the temperature or the climate change. But like in short and short, the certainty is not with the data. The data that we collect, or the information, the knowledge we have, we are not certain with that knowledge. Now, over all in all, we have uncertain knowledge, uncertain data, and then we have the issue of uncertain knowledge representation and the interference. These are the four broad, you could say, the areas where the system has to work on. So uncertain knowledge is that it is not certain, and it may be incomplete, and it can cause any, you could say, causality or any issue with the system or issue with the machine. Uncertain data is like data is missing or unreliable or inconsistent, or it's noisy, or it's not clean, it's tangled. And then if we are representing that uncertain knowledge to the system, uh, in the real world example, that might cause any issue. So for simple example, in AI models we are developing self-driving cars. So in those self-driving cars, we want to have a certain uh, systematic knowledge, like a certain data which the model is trained, because the AI model that runs on car, that direct the car in which lane it has to go, or in which direction it has to move, it should work on the reliable data and the reliable knowledge. If it was trained on something which was not reliable, it can cause accident. So the knowledge representation is very necessary for all these things. Now, the uncertainty can be dealt with three things. One is the probabilistic theory, like adding the probability in the machine learning. And in machine learning, probability is one of the, like, you could say, the most important field or most important branch. And then truth maintenance system. So in the truth maintenance system, we actually like try to build those systems uh, which are basically correct, like which are predicting, or you could say implementing the truth rather than creating some uncertain situations. And third is the fuzzy logic. So I'll talk about the probability theory here. And we apply the probability or the basic probability to find out the certainty in the uncertain knowledge, to make the knowledge representation certain. And this is to make it uh, this is done to make the uncertainty certain. And because uh, you could say that in the probabilistic reasoning, when we use probability, we handle these uncertainty, because in the real world scenario where the certainty of something is not confirmed, such as whether it will rain today or not, or behavior of some situation, then or a match between two people, even a toss of a coin, on those things, like we can apply probability. So whether it will rain today or not, we are not sure with with anything, even with all the prediction and not. So we apply probability, okay, whether it will rain today or not. So uh, these are the probable sentences or situations for which we can assume that it will happen, but not sure about it. So here we use the probability reasoning, like all these situations, whether like we are not certain and there is some uncertainty in the knowledge, uncertainty in the system. So we use the probability to find out the certainty or to make the knowledge representable or make the knowledge certain. Uh, So, what is the need of probabilistic reasoning in AI? Like I said before, when the outcome is unpredictable, when the situation or possibilities of predicates become too large to handle, or when an unknown error occur during experiment. So, in all these circumstances, in the probabilistic reasoning, the two ways that we handle the problem is, one is your base rule and your statistics basically. So statistic like Bayesian statistics, or the base rule that we use, or the probability we can say, to handle this unpredictable outcomes. So probability, has been know, like it's a simple thing. It's a chance of happening something or an uncertain event, uh, at what likelihood some event will occur or not. So probability of an event is always between 0 and 1. Like the probability will happen 100%, then the probability will be 1. If that event will happen certainly or 100% of the time, or the possibility of that event is not happening, or we can say that that event will not occur, then the probability of that event is 0. So probability of any event is between 0 and 1. And when the probability of something is 0, we can say that this is uncertainty in the event A, or event A will not happen. Or when we say that probability of a event is 1, we can conclude that certainly this event is going to happen. So this is the probability of the event A. So uh, basically, probability of a event A plus probability of that event not happening is always 1. This is a basic fundamentals of probability. Like probability of something happening plus probability of something not happening is always 1. And event, these are the terms, basic terms, like event is some outcomes, or the all the possible outcome of a variable. Like tossing a coin has an outcome of head and tail, or tossing it twice has an outcome of head tail head tail, or anything like possibility of a uh, happening rain is, if I talk of uh, in the terms of yes or no, then it will rain or not. So sample space is the collection of all the possible events. For for tossing a coin twice, it is head tail. And random variables are anything that happens within those sample space. And then the prior probability. Uh, so these are the theoretical things in AI, like something which is the probability, or which which is computed before observing new information, and posterior probability, and it is calculated after all evidences or information taken into account. It is the combination of prior probability and the new information. So these are the basic terminology in probability. Now, what are the axioms of probability? So they are basically three. One is the probability of the event. So it's like whether one event is happening or not. Though this is called as first axiom, and it is the first one is the probability of an event. It is always between 0 and 1. 1 indicates that definitely the outcome will occur of that for that event, and 0 indicate that no outcome is possible. Second axiom is the probability of sample space. So we can say that whole sample space, like all possible events combining, or the entire sample space, the probability is 1. And the third axiom we could say is the mutually exclusive events. So it is like there are two events, but they are mutually exclusive, and they are disjoint with each other. So outcome of one is not related to other in any possible way. So these are the three axiom of probability. As I explained before, like in probability, uh, probability of a event is between 0 and 1. If there is a sample space, like n sample space, and for that sample space, the count of that event is, let us suppose, c. So the probability will be c upon the sample space. uh, so this is the first axiom, which for which the probability lies between 0 and 1, and we divide the total number of outcomes in the event by the total number of outcomes in the sample space, and the event in the subset of a sample space. So the event cannot have more outcome than the sample space. So this value lies between 0 and 1 because the sample space is always larger than the event. That's why the probability is 0 to 1. Then the probability of a sample space which sums up to the 1. So this is one example, that there are four outcome with certain probability. So there are four females and one is salaried, three are unemployed, and then among those, one is churn, zero non-churn, two churn, one non-churn. So if we'll try to find the probability of all the events, like this one, so 0.5 plus 0 plus 0.5 plus 0.25, and we add up, so probability of sample space is 1. So basically, the second axiom, or you could say the probability of complete sample space is 1. And the third is the mutually exclusive events, which is basically when two events, they are mutually exclusive, which means that they cannot occur together, or they don't have any common value. So we can say that uh, they are they are not related in any way. So say their intersection is 0, like the possibility of having them together is 0, like that. So for the mutual exclusive events, this is the third axiom, and we can say p probability of a event with the union b is probability a with probability b. So these are the three axioms. With this is very basics in probability, and we use actually Bayes theorem, which I'll tell, Bayesian system and Bayes theorem in the probability. So next is the conditional probability, and it means that probability of any event when something has already happened or occurred. So let's suppose we want to calculate the event A when event B has occurred. So the probability of A under the condition of B, it can be said that uh, P joint B is probability of A union B uh, uh, with B. So PB is the marginal probability of B, and if the probability of A is given, we need to find the B. Then we can write it like P, probability of B joint A is probability of A intersection B divided by PA. So this is the conditional probability. Conditional probability is basically uh, the probability of happening one event when we are certain that something has already happened. So this is the conditional probability, and we can say uh, this is the Venn diagram of conditional probability, and in this there are two events. One event is A, other event is B, and this is uh, the common area, or you can say the A intersection B is the area. So this is one like simple example. If there is a class and 70% student who like English and 40% student who like English and maths both, then what is the percentage of student who like English and also the mathematics? So let's A event be the student who like mathematics, B like English. So 57% of the student who like English and also the mathematics. So we can calculate something like this: the probability of A when we know that B is happening. So with the formula, if I put, it will come out to be 47%. So now I'll move to the Bayes theorem, or the Bayes uh, rule, or Bayesian reasoning, and how it is important in the AI. So Bayes theorem is the Bayes rule which determine the probability of some event in an uncertain knowledge. So in the probability, it is related to the conditional probability and the marginal probability of two random events, and using the Bayes theorem or the Bayesian interference, uh, or the application of Bayes theorem, which it is fundamental to the Bayesian statistics. So we calculate the probability of uh, B with related to A when we know that probability of A when B is happening. So this is what the Bayes theorem is. It allows to update the probability prediction of event by observing new information. Uh, for an example, uh, like if cancer corresponds to one age, and by using the Bayes theorem, we can determine the probability of cancer more accurately with the help of age. So Bayes theorem, it can be derived from the product rule and the conditional probability of the event A with known event B. So we can write like probability of A intersection B with probability with the conditional probability, or P probability of A when B is happening and PB. Similarly, for probability of A intersection B, we can write probability of B intersection A with PA. So if we can equate these two equation, we can find that this equation, which a Bayesian equation, that probability of A when B is happening, it can be calculated using probability of B when A is happening into PA divided by PB. So this is basically your Bayes theorem, and Bayes theorem or the Bayes rule. It's a relationship between conditional probability, and we can actually, what we can do is we can extend this Bayes like two event rule into the n event rule from AI to an. So we can say that when n events, we are know that when how and when n events are happening, we can find the probability of B. So this is the Bayes rule, and using the Bayes rule, we can compute this probability of some event with related to A in the terms of probability of first event with related to B, and the probability of individual event. And we can use this in the you could say finding the prediction or the finding the output in the Bayesian system, in the calculating some data related issues. So how we can apply this Bayesian theorem in the AI system? So what we basically do is that make classifier like Bayes optimal classifier or an IF based system. Basically, we use probability in AI or machine learning to fit a model to a training data set. So in that, suppose the we are developing the model, and we are trying to do some kind of classification predicting modeling. So we use Bayes optimal classifier and naive Bayes, and we can also use this Bayes theorem for other things like when we don't know how some machine or a robot is going to execute the next step, so we can use to try to predict that. And we can use in other computer science related problem like whether for forecasting or a Monty Hall problem, all these things. So this is how we apply Bayes theorem in artificial intelligence. uh, i'll I'll end my presentation like for the first part. Now I'll move to the second presentation, which is related to the project that I currently working. So the project I was recently working, it was a signature forgery detection. So basically, when we make signature in a bank or in a IT department or in an income tax department and all those places, there is always a chance that someone can forge a signature or someone can duplicate it. So can we build a neural network or a AI model which can detect signature forgery? So this is one project which was based on one paper, and it was convolutional Siamese network for writer independent offline signature verification. Right, this project I worked on, I trained the model and I tested that. So I'll tell you the overview of this project. What happens is that there are two types of signature verification, like signature happening, like signature in two ways we can take the signatures. One is in a hardware, dedicated hardware or a tablet. Let us suppose a company or a firm makes a dedicated hardware to take the signature. In that, when we do the signature, not just the signature is recorded, but other parameters are also recorded. So someone's writing speed, someone's flow, and the tilt and the pressure, all the things can be recorded. So next time other person will try to do the signature or will make the signature, that data can also be checked. So let us suppose I make signature with more pressure in comparison to you. So that's and I'm forging your signature, like I'm trying to copy your signature in a tablet, or I'm writing it slowly. So that system will detect, okay, this signature is not matching because the speed is not there, the pressure is different, the tilt is different. So one can develop a such type of system that is called as online signature verification. But we cannot implement it easily because the hardware cost is very high. Like every department has to like buy those hardware, and there must be some firm who can which can build such hardware. The other type of signature verification is offline signature verification, which often and normally banks and departments they do with their naked eye, like that on papers. So when we do signatures on paper, that's your offline signature, and then that paper is scanned and stored in the form of images in some databases. So in banks, you might have seen that bank manager or the bank employee, they verify your signature by visually looking into it. So for that, we can develop some AI model to detect that whether the signature is genuine or a forged. Like your there is the database of original signature, and a new signature is provided to match with the original signature. So one way we can do is here we can develop a writer dependent neural network. What it will do, it will get trained with all the signature of the people, like of that. Let us suppose there is a bank and it has 1000 customers. So it will trained with 1000 signatures, and next time someone will go and write his signature, so it will match with that 1000 signature and check that whether it is genuine or not. But with this system, the problem lies that every time a new signature or a new customer is added, you have to recalibrate the whole neural network. Like, like whole AI system, you have to retrain it again, right? So this system is like a flawed, not a flawed, but it needs a lot of effort. The second type of offline signature verification, which I worked upon, is writer independent. So in this, the model is as such, it needs least amount of data for training, and it can identify the forgery in the signature. And how it does, it uses Siamese network, uh, which is using two convolutional neural networks simultaneously. For an example, how we do is we give this network two signature, a group of signature. One is, one pair is genuine and other pair is forged, like one genuine and one duplicate, like a forged one or a copied one, or someone has tried to it. And we tell the model that learn how we can identify the differences between two signature. So what we do is that if the signatures are genuine, they will they will find that okay, they will the model will run, the model will get trained as such that it will reduce the Euclidean distance, like model will reduce the uh, distance between the signature. And when the signatures are forced, it will increase the distance. So eventually in that in the end, after the training, it will be able to identify okay, what type of signatures are genuine and what type of signature are forged. So before that, before moving to the Siamese network, like how it works, uh, this is a general picture of a fully connected neural network. Like there, the fundamental unit of a artificial neural network is a neuron, and in a neural network, all these neurons are connected with each other, and with one input layer and one output layer. And output layer, what it does, it classifies things or predict things, whatever the model is all about. And the input layer is the data that we give it to the neural network. In between we have the hidden layer, like they basically try to calculate some features or parameters in like that, and in the end we get output. So this is your fully connected neural network. But the problem with such neural network, if we implement it in image classification, there is lot of computation. So these are millions and billions of neurons, and you have to do like a kind of infinite calculation. And to do that, you need a lot of like GPUs, a lot number of GPUs to train the model, and hours of training. So to compensate the computational overhead, or to compensate the computation in the hidden layer, we can use the convolutional neural network. So this is an advanced version of neural network, you could say, or a type of neural network, you could say, in which rather than connecting all the neurons with each other, we make a convolution to with the inputs we have. So we have you could say the input image, and we do the convolution. And after the convolution, the inputs, like the size of the matrix or the size of the data, gets reduced. And after that we do the ReLU. Like ReLU is basically your uh, activation function. So it's a part of theory of neural network. Then we do the pooling. So pooling also reduces the size, and we repeat all these things again and again. So convolutional ReLU, pooling, convolutional ReLU, pooling. And from here we try in, so through convolution we try to identify features in the images. So if there is a car or a bus, so we see that okay, uh, does it has like two bulbs, four tires, like this we try to identify features. So there are multiple layers, feature layers, and we do the feature mapping here. And after doing the feature mapping and doing the pooling and all, we flatten the layer, and then in the end we connect with the last layer, which is the your fully connected layer. This is, and in the end we classify or we predict the output, and we train the model as such that whatever the parameters are inside, they will change through back propagation, and we classify. So this image is truck or a van or a car or a bus, all these things this neural network will able to identify after training. So when we first we train it, then we can give any input image to test it, right? So there are some parameters here in the Siamese network that I used in the offline signature verification. There are two similar new convolutional neural networks. So convolutional neural networks are used to classify images. In this, the neural network is not classifying the images. So there are two signatures, uh, one and two. It is not classifying, but it is learning the differences and the similarities between the features of images, between the features of signature. So when I gave similar signature like genuine and genuine, so it will reduce the loss function, right? And when I'll give a dissimilar, it will increase the loss function. Loss function is the, basically you could say, the actual output and the predicted output in simple terms. So what it is actually doing, it is learning that what 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 group is similar, what group is dissimilar, and according to the feature it is getting training and training and training. And to bring the parity, like bring the uniformity, the number of sets in the data of similar signature and the dissimilar signature is equal. So this Siamese network, it is different from a convolutional neural network as such. CNN networks are used to classify images. They do it into certain categories. So there might be 100 categories of images, 100 categories of vehicle, and the network is made to learn those features and then classify them according to those 100 or 1,000 features. But this Siamese network, it is not meant to classify it. It is only meant to identify the similarities and dissimilarities between two uh, two input images or the two signatures. And here we have one convolutional neural network, and here we have one convolutional network, and both the network are exactly the same. The parameters of both the weights of the both the CNN, the parameters, the structure, the input layers, all the things are the same. Like this is the copy of the other model. Only thing is it is meant to find the difference and the similarities. In the end, it computes the lot function, and finally it gives the output that whether it is a similar or a genuine signature or not, or it is a similar or a forged, it's a dissimilar or a false signature. The loss function that I talked about is a contrastive loss function. So loss function is basically, let us suppose you make a prediction line here, and this is your actual output. So difference between the actual data and the predicted output, that is the your loss function or the loss value, and you minimize it. So this is your loss function. Similarly, in this Siamese network, the loss function is your contrastive loss function, which is your L S1 S2 Y. S1 S2 is the signature, alpha beta is the your constant, d square is the distance or the Euclidean distance. Basically it is the distance between the model. So sorry, signatures. So what it does is that when the input is similar, S1 S2 is similar, genuine, so it will minimize the distance, or when it is dissimilar it will maximize the distance. So this is the contrastive loss function. This is one example. Like this is the model, and this is the feature. Like for a signature there is one curve. So for an example, someone's signature has like has this curve or this curve. So this can model can learn that okay, this variation is similar because I'm giving a similar tag with it, and it will take this as a input, but this is not similar. So someone writing a signature with this curvature and a straight line, so the model will understand, okay, or the model will get the input that this is not similar. So this is how this contrastive loss function works. uh, this is the actual Siamese network, like the all the parameters inside it. So initially we have 11 convolutional layer, then ReLU function. This is the initial one. Then we have again 5 cross 5 convolutional layer and 3 cross 3 convolutional layer. We have the 2 cross 2 max pooling, and we have the local response normalization and the dropout. So these are the terms that are related to AI and the model training. Max pooling is like we took the maximum value from 2 cross 2 matrix. So we have, let us suppose, 10 cross 10 matrix, and we pick one element from 2 cross 2 and put it into another matrix. And when we do that, we we basically reduce the size of the matrix. So you can see that from starting till the end, like till here, the size of the matrix is getting decreased, or it got decreased just because we wanted to decrease it so that we can train it easily. Like for a convolutional neural network, the idea is that the size should get decreased in the end. And we also do the dropout, like we randomly switch off the some neurons so that it will not do the overfitting the things. And this, in the end, we have this loss function. So this is the two signature which are very similar. So suppose these are the two signature which is which are uh, which is done by the same person. So when we'll give this to this model for training, it will minimize this loss function. But if there is a first one, it will maximize it. This is the actual parameters or the numbers of this. I think this is the beyond the scope of presentations tried and flag. This is the training part of it. uh, uh, so it took around an hour for training, and in the end it predicted some values like equality and distance. So for original pair of signature, the distance is less, and for first pair of distance signature, the distance is high. So this is how the the signature verification project works. Any questions from this presentation? I can like present the code and all, but I think that is beyond the scope of presentation because uh, that is not easily understandable. Any questions from the presentation?
Students, if you have any queries,
No, sir.
no. Okay, you can tell any feedback about the today's session. Anyone can turn on your mic, and then you have to say something about this session. Tell the feedback about the session. Praveen,
Yes, sir.
yes, you can tell me the feedback of this session.
Fine, sir. Better இருந்தது சார். ஆக்சுவலி நேற்று வந்து ப்ராபபிலிட்டி பத்தி பார்த்தோம் சார்.
Okay,
இன்னைக்கு வந்து இன்டெலிஜென்ஸ் அந்த நாலேஜை பத்தி அது ஏஐ ரிலேட்டடா எப்படி அது கொண்டு போறதுன்றது சொன்னார் சார்.
okay, then
பெட்டராகவே இருந்தது சார்.
better. Okay. Then what about others? What about others? If you have any queries, put in chat box, or you have to turn on your mic and then you have to share your experience today's session. No queries. If you have no queries, please put it in chat box. That is also. If you have no queries, type in chat box. No queries. Second years. If you have no queries, put it in chat box. Please, no queries. No queries. Very good, Muthu Prabhakar. What about others? Okay. Abhishek Sharma, sir.
Okay, sir.
I think
I'll.
most of the students are not having any queries. Okay.
Okay, sir.
So now I'll convey my vote of thanks, sir, once again. Okay.
Okay, sir.
So good morning. This is such an honor for me to get the opportunity to thank you all. On behalf of the BCA department, I extend a warm welcome to the participants in the gathering. First of all, I extend my gratitude our chief guest Abhishek Sharma to take out the time to grace the event, and then he shared the valuable concepts in the AI, and then he encouraged the students with us. So on this special day, sir, thank you. And then a special thanks to Dr. Agasthias, HOD of BCA department, for providing immense support to make the workshop successful. I must thank the organizing coordinator, T.S. Suganya ma'am, P.F. Kavita ma'am, and Shamla ma'am for working hard for the past few days to make this workshop successful. So once again, I congratulate all the participants for the active participants. Thank you everyone once again for make it a great success. I thank over the object automation team to conduct these workshops. Thank you, sir. Thank you, Abhishek Verma, sir. Thank you.
Uh, Thank you, sir.
Thank you.
Thanks, team, for providing me the opportunity to present on some wonderful areas that I'm working on.
Okay.
So I'm really grateful
Okay.
for
Thank
the
you.
opportunity. Thank you, sir. Thank
Well,
you, sir.
I also listened the today's session, sir, fully. So I am only taking the artificial intelligence for the students. So
Okay, sir.
I also got some information regarding this. Thank you.
Uh,
Project is also well done, sir. Okay.
yes,
So
sir. I worked on this image verification project on the Siamese
okay,
Network.
okay,
So it's a
okay.
good project that I worked upon, researched upon,
Okay,
and
okay, okay.
okay, sir.
Okay, very good, sir. Thank you. Thank you, sir.
Okay, sir.
Thank you, Abhishek. Thank you.
Thank you, sir.
Thank you, Abhishek, sir. It was really wonderful session, and it would be great if you just share the recordings so that students, if they have any doubt, they can just have a look on the presentations.
Okay, sure, sure, sure.
Thank you, sir. Thank you. Thank you all. Thank you.
Yes.
Sir Abhishek, is that session over? Sorry, I was in the call actually.
Yes, ma'am. Session is over.
Okay, thank you. Thank you, Jayachandran sir. Thank you, Abhishek. Thank you, team.
Thank you, ma'am. Thank you, ma'am.